The answer to this question is simple, because I didn't have any. But it's much more complicated than that. Sure, I have the Boss Katana amp, which has all kinds of effects on it. And I also have a bunch of plugins, and they're all great, but not having analog effect pedals, which I can tinker with, has left me feeling like not a real guitar player. A long time ago, I used to play keyboards in a few local bands, so I've always had a passion for music. But it wasn't until about a year ago when my crush turned into something more. That was when I decided to start practicing playing guitar. I have tinkered with the guitar in the past, but I wasn't any good at all. This time I did it kind of right. First I learned a few riffs, then I learned a few songs, then I started practicing some techniques like bends, some tapping and whatnot, and finally I came upon something that everyone is talking about: tone. I like heavier music, but not too heavy. I also like modern music. I'll just casually mention Polyphia, Sleep Token, Tesseract, and the band that got me into heavier music, Periphery, and so many more. Of course, Tim Henson is my idol. Scotty, I love you too. I'm getting sidetracked here. So I discovered tones. I don't really understand tone that much, but when I hear different tones, I can tell which ones I like and which ones I don't. When I didn't have the amp, I was plugging my guitar straight into my sound card, and I used various plugins in my DAW. The problem was, there were too many controls, the noise gate was often too high and was cutting the sustain, and I didn't really know which knob to move and what it would do to the sound. Being an ex-keyboard player, I spent thousands of hours creating synth sounds on my Kurzweil, modifying sine waves, adding filters and whatnot. I wasn't gonna do it all over again. That is time I can't really get back. So instead of tinkering with the plugins, I decided to look into effects pedals. There are millions of pedals available, so how is one supposed to figure out which one to buy? Most of them are not even that cheap. Here comes the fun part. Being also a tinkerer with electronics, I decided to build my own. I knew I wanted some distortion or overdrive. Then maybe a delay pedal, maybe even a chorus. It didn't really matter, I just wanted to build stuff. So I searched for tutorials on how to build pedals, how to modify circuits. I had a box of transistors laying around, and thankfully I had a few of the most commonly used values. So I found the most basic circuit I could find, and I built my first pedal. Well, it wasn't a pedal yet. It was just a circuit board connected to a couple of audio jacks, but it was working. There was buzzing and humming, but above all that I could hear the sound of the overdrive. That was it, I was hooked. I scavenged Temu and AliExpress and ordered some pedal switches, LEDs, different types of capacitors, resistors, op amps, and now I have 1,000,001 parts at home. Then I played around with a few more circuits. I found one that I really liked, the DOD250 Overdrive preamp, and I modified it a bit by changing some capacitor values to get rid of some noises, tested it, and I decided to turn it into my own PCB. I'm not saying that I created the schematic, I just liked it so much that it was easier for me to remake it using a custom PCB instead of soldering it by hand every single time. I'll link the original schematic and my modified one in the video description. So, as usual, I fired up EasyEDA, created my schematic and took the Gerber files to JLC-PCB, the sponsor of this video. JLC-PCB is a high-quality PCB manufacturer that makes the highest quality PCBs for the lowest prices. Everything from production to shipping goes smoothly and quickly. I received my PCBs in about 7 days after they were shipped. JLC-PCB provides the lowest pricing even on 6-layer PCBs. JLC-PCB is a one-stop shop for all your project needs. They provide flexible PCBs, PCB assembly, SMT stencils, 3D printing services, CNC machining, mechatronic parts, and more. The ordering process is straightforward and intuitive. You simply need to get your Gerber files, drag them onto their website, and you can get an instant quote. For the PCBs, you can choose various customizations such as thickness, color, soldering material, and more. The best part is that you can get 5 boards up to 10 by 10 centimeters for only $2. Get your PCBs made by JLC PCB today by signing up with the link in the description. So I'm going to show you how I put together this guitar pedal, and later we'll do a sound test and I'll show you some of the other pedals I built in the past couple of months. I'm sorry that I haven't released a video in 2 months, but I really wanted to understand at least a tiny bit of the circuits before I presented them. This is the schematic for the overdrive, which is fairly simple. First I added another 100 microfarad capacitor and I changed this 10 picofarad capacitor to a 68 picofarad one. This eliminated most of the noise I was initially getting. This would be the input stage. This is where the 9V power supply voltage comes in. This here is the gain stage. And through the op-amp, we then have the clipping stage. And the output comes out of the 100K logarithmic potentiometer swiper. So I received the PCBs, which looked amazing as always, and I was eager to test them out and see if they actually work. I know you already saw my set of components, but let's just go over some of the parts we're going to need for this build. So here they are. Ceramic capacitors, multiple values. Electrolytic capacitors, multiple values. 1N5819 or 1N5817 diodes. A bunch of resistors. The LM741 operational amplifier. Some wires, I like black for ground and red for the rest. An 8-pin IC socket for the chip. A DC jack, these are usually standard for through-hole mounting. A 3PDT switch. A 500K linear potentiometer for gain. A 100K logarithmic potentiometer for volume. A couple of 1/4-inch mono audio jacks. A 5mm LED, I chose a green one but I later switched it for a yellow one. A couple of 1N4148 diodes for clipping. And these are some must-have tools. Then finally the enclosure, which is a 3D printed one, and you can find the model in the video description. I didn't make it, all the credits for the model go to the original creator. Let's start with the resistors. I made the PCB in such a way that even if you don't have the schematic, you can still see the names or values of the required parts. For this build we need 5 1MΩ resistors, so let's start there. We can proceed by adding the rest of the resistors, and this is what the board looks like with all of them. Now let's add the diodes. First we can add the clipping diodes, and the polarity is clearly marked on the PCB. Be careful not to add them backwards, same goes for the other diode. Now we can solder them to the PCB and cut out the excess legs. Since I built this fume extractor, I can't imagine soldering without it. Thanks to everyone who suggested I should get one. Now we can tidy up a bit and proceed with the capacitors. This is what the PCB looks like with all of them in one place. Then we can add the IC socket. This too has the correct orientation marked on the PCB. And this is how I try to figure out which electrolytic capacitors I need by counting the columns and rows on the label. That's all the components for the PCB. Now let's prepare the switch. I link the first two columns on the first row together. Then I'll add some wires, which I will later connect, because now it's time to mount the switch to the enclosure. We can also mount the DC jack at this point, as well as the potentiometers. So the left one is gain and the right one is volume. It's already starting to look like a real pedal. All it needs now is the brains. On the PCB there are soldering pads for the LEDs, the potentiometers, input and output, 9 volts and ground. That's what these wires are for. So I'm soldering the LED's positive leg to the second row and the third column of the switch, and the negative one to the PCB. Then we can mount the input and output jacks to the enclosure and proceed to make the rest of the connections. If you want to follow along, I've skipped a lot of the soldering, but you can just refer to the schematic. And finally we can add the 3D printed LED holder and hot glue the LED. Since the PCB doesn't fit on the bottom of the enclosure or the bottom side of the top of the enclosure, I decided to mount it to the side with a bit of hot glue. So far all the pedals I made have shown no signs of moving around. Finally we can add the lid and screw it in place. And you know what it is time for, adding the caps so the DIY 3D printed guitar pedal becomes a real guitar pedal. So what do you think? I think it looks gorgeous. Now let's do the sound test. I've never done a sound test before, so I'm not really sure what I'm supposed to be doing. I just mic'd up the Boss Katana and started recording. So here is the pedal we just built. It has a gain and volume knob and it's supposed to be a light overdrive. This is the true bypass clean tone. Now let's hear the pedal. Let me show you the next pedal. This is a distortion pedal that I built from watching a YouTube video. It has a volume, gain and tone knobs. This distortion is pretty mean, and it has a high-pitched ringing sound that I'll probably try to fix. If I turn my guitar's tone knob all the way down, the high-pitched noise seems to disappear. This pedal used to be a massively huge fuzz, but something happened to it right before I started recording. It is based on the Creepy Finger CQ exciter. It has a gain, volume, and even an EQ knob. Here I'm having a hard time with it, but it did sound massive before. This tiny pedal is a massive fuzz pedal, based on the Color Sound one-knob fuzz. I just need to switch the potentiometer so it's not always all the way up, otherwise just have a listen. This is probably the pedal I'm having the most fun with. It is a delay pedal based on the PT2399 module, and I made it following Rob Mods' tutorial. Something also went wrong with this pedal before I started recording. It started humming, but otherwise it is a very fun pedal to play with. If you made it all the way here, thank you for watching. Let me know in the comment section if you'd like to purchase a complete kit, a pre-built pedal, or just the PCB. In the meantime, you can find it as a product on my website, the link is down in the description. Purchasing a pedal helps the channel stay alive, so if you'd like to support me and the work I do, feel free to get one. Thank you for watching, my name is Risto and I will see you next time.